Okay, this is section 1.7 and it's on rewriting formulas. There's no journal for this section because I want you to start preparing for the test. Okay, objective and what's the point? This is a quick little section. Basically, you're going to find this section has a lot of applications, especially in science and obviously your math classes. You are given formulas all the time. Sometimes it's helpful to rework the formulas so that you can solve them for a different variable than the one that is isolated already. This may require some tricky algebra, and you will find, if you get really good at this, that you'll have less formulas to memorize because a lot of times you'll be given a set of formulas when they're all the same thing. And if you just would have used algebra, you wouldn't have had to memorize them all. You could have just memorized one and then moved stuff around using algebra. So it's a pretty good section. You'll see what I'm talking about in a minute. Okay, words to know. Equivalent formulas are formulas that have the same values of variables that satisfy them. Basically, formulas are equivalent when you play around with them algebraically following legal rules. So, for example, let's say, how about this? 2L plus 2W equals P. This is perimeter of a rectangle. 2 of the lengths plus 2 of the widths equals your perimeter. That is the same thing as 2 lengths equals the perimeter minus 2W. What did I do? I subtracted 2W from both sides. Those are equivalent formulas. A hint, this will show up in your homework. You may want to distribute if a variable shows up more than once. Then after you distribute, you might want to get the variables on the same side and then factor out a GCF. If you remember how to factor out a GCF, if we have like 4G plus 2GH equals, okay. You can factor out, oh, they both have a G here. Let's factor out 2G. Then I'm left with, this is not very helpful in this case, 2G plus H equals K. That was actually a really bad example because the G still showed up. But if I had another 2 there, it would have gone away. Basically, you might have to factor out a GCF if the variables show up more than once. Again, that was a really bad example I gave you. Pretend that didn't happen. When it comes up in your homework tomorrow, I'll be happy to help you with it. Remember, fractions come with an automatic set of parentheses. And basically, we're not going to learn anything new today. If the formulas you encountered today had numbers in them instead of the variables, you would know exactly what to do. Basically, today you just need to make sure that you don't let all the extra variables fool you. Okay, example 1 is talking about a pendulum. Do you guys know what a pendulum is? Like on the grandfather clock. This is a really bad picture. The tick-tock thing. Tick-tock, tick-tock. That's a pendulum. Okay, the period P of a pendulum is the time in seconds that it takes a pendulum to make one complete swing back and forth. So from this point back to that point, the exact same point. That's a period. Here's the formula, okay? P equals 2 pi times the square root of L over G. L is the length of the pendulum in meters. G is the acceleration due to gravity. You'll come up with that when you do chemistry or your science classes. It is a constant. It's always 9.8 meters per second squared. They're wanting us to solve this formula for L. Let's say that we wanted to figure out not what the period is, but we wanted to figure out how long my pendulum was. So how can I get L by itself? Okay, you first here, and I made this kind of sloppy, P equals 2 pi times the square root of L over G. Okay, I want to get L by itself. So the first thing I'm going to move is what's the easiest to move, and that would be this 2 pi. The 2 pi is being multiplied by the square root, so I'm going to divide both sides by 2 pi, just using algebra. So I have P over 2 pi equals the square root of L over G. Does anybody remember how to get rid of a square root? Well, since no one's here to answer me, I hope someone on their computer is saying square both sides, and you're absolutely right. That will get rid of the square root. So now I have, I'm going to go to my work page here, p over 2 pi squared equals, what do we have here? The square root of L over G squared. Okay. So this gives me p squared over 2 pi squared, because remember that's saying p over 2 pi times p over 2 pi. When you multiply fractions, you multiply the top, keep them on top, multiply the bottoms, keep them on bottoms. So that's 4 pi squared, which looks a little weird to you guys, I'm sure. P squared over 4 pi squared equals, the square root will cancel with the square, so I'm left with just L over G. Trying to get L by itself, so what do? I multiply both sides by G, and I get P squared G over 4 pi squared equals L. We're done. You might have left it like P squared G over 2 pi squared, and that would have been okay too. There's a couple problems that you could write them slightly different ways and they are still correct. Okay? So what is the approximate length of a pendulum whose period is 1 minute? This is whenever it's nice to move the formula, because if I know what the period is, if I plug it into the original one, it's going to be messy. 1 equals 2 pi times the square root of L over G. That's pretty messy, but if I go to my new one and plug in 1 for a period of a pendulum is a time in seconds, so that was wrong even. I'm not plugging in 1, I'm plugging in 60. So let's go back to my work page. Here's my formula. P squared, so that's 60 squared. G was given to be 9.8 over 4 pi squared equals L. This is a calculator problem. $60 squared times 9.8. I have 35,280 over 4 39.478-ish. I'm putting ish because that decimal goes on. I divide. And I got 893.65. And we're talking about, I believe, what is the unit here? Meters, because we have meters per second squared. So that's going to give us meters, yes. Oops. Meters. That's a big pendulum. They used to have some of those like at museums and stuff, and stairwells. I don't know if anybody's seen one like that, but they do exist. Okay, next one is about scuba divers. Because the density of air consumed by scuba divers increases as they dive deeper, they consume more air the deeper they dive. The formula T equals 30S over D plus 30 is used by some scuba divers to estimate the number of minutes, and that's time, T, of air they will have at a depth, D, in seawater, if they consume a tank of air at the surface in S minutes. Solve the formula for D. So I want to get D by itself. This is something a lot of students struggle with. Rule number 1, if the thing you're looking for is in the denominator or the downstairs of a fraction, you have to get it on the upstairs first. So the first thing we're going to do is move that D plus 30 out from underneath of that fraction. We need it out of the denominator. So the way we do this is we multiply both sides by the quantity D plus 30. I want to get rid of that fraction because you cannot solve by something if it's on the downstairs or in the denominator there. So I have now d plus 30 times t equals 30s. Okay, I'm trying to get d by itself. Some of you, as soon as you see this parenthesis and a number outside of it, immediately want to distribute. You can, but it will just make you have to do one extra step, okay? What I'm going to advise you to do is think, I want to get d by itself, so who do I need to move first? I'm going to move that t. They are being multiplied together, so just divide by t. So now I have d plus 30 equals 30s over t. Got to get d by itself. Last step is to subtract 30 from both sides. That is one piece. This is the second. So now I have d equals 30s over t minus 30. It's really important that that 30 is separate from that fraction. Okay? Let's say that you did distribute here. Then you would have had what? TD plus 30t equals 30s. Again, this is not a big deal if you did it that way. I could still get d by itself. I'm just going to subtract 30t minus 30t. So now I have TD equals 30s minus 30t. And I will finish by dividing both sides by t. And this looks a little different, but it is the same. 30s minus 30t all over t. This is equivalent to this. Okay? A little fun fact, I don't know if it's fun for you, but I thought it was interesting in case anybody was a diver and they want to tell us more about this tomorrow. It says that recreational scuba diving, it's actually kind of limited to 120 feet deep because it says it's not about the available air. You can get a big scuba tank apparently, but the amount of nitrogen absorbed by the body. So in case you're going scuba diving, you need to stay above 120 feet. Okay. A certain ancient pyramid has a volume of x cubic meters. Each side of its base is 231 meters. So solve V equals 1/3 big B times H for H. They want us to get H by itself. You should have seen this formula before. This is volume of a pyramid. 1/3 big B is actually area of the base. Do you guys remember this from geometry? In which this case will be a square. H is the height. We're trying to get height by itself. Okay, so I want to get height by itself. So do I divide by 1/3? You can, but that's not how we usually do it. We usually say we're going to multiply by 3 to get rid of the 1/3. So now I have 3V equals big B times H. Get H by itself, divide by big B, divide by big B. 3V over big B equals H. Assume that the pyramid has a volume of massive 2,614,689 cubic meters. What is the height? Well, I have 3 times 2,614,689 equals the height. And we need to figure out what big B is. How can I figure out what big B is? Well, it told me that 231 meters was the side of the base. Big B is the area of the base, so I have 231 times 231, that's the area of a square. That is 53,361. So 3 times my sloppy 2,614,689 divided by 53,361. And let's see what we get here. 3 times 2,614,689 divided by 5,361. 147. The height is 147, and we are talking about meters. The tall pyramid. Okay? Good luck on your homework if you want to get started on it. It is an easier section, so I think you can do some on your own. I'll see you tomorrow.